Number 12, greatest even factor of 180 that is less than 90, or the greatest odd factor of 180. Okay, so here, again, it's just sort of a basic technique, can you do it, right? How are we gonna figure this out? What do you guys think we should do?
You can brute force it with algebra, but it'd take too much time.
Yeah, I think the easiest way to do this, the main problem with this is this idea of the greatest even factor, greatest odd factor, is if you're thinking about it and you're looking at it, you always might be wondering, how do I know I got all the factors, right? That would be the part I would be concerned about, is maybe there's one out there that I forgot that isn't there. Do you guys remember how to find all the factors and know that you found all the factors?
The tree?
Yeah, so you just do the factor tree and then you look at the combination. So you take 180 and you've got, 90 and 2, 45 and 2, 45, 3, 15, 3 and 5, right? So the factors are 2, 2, 3, 3, 5, right? Okay, so 90 would be 5, 3, 3, 2, right? So that would be 90. So we got to go something less than that. Right? What do you guys think we're going to drop out of there to make it go smaller, but still leave us with the greatest one? And keep it even.
Well, it's going to be 2.
So if we drop the 2 out, it would be 45, right? So that would be an odd factor. So we have to leave the 2 in there.
So it should be 3.
Yeah.
So
2 times 3 times 5. What do you get with 2 times 3 times 5?
30.
You get 30. Does that sound right to you guys?
Mm-hmm.
What if we bring this 2 down to? Then we've got 60. I guess this is sort of, I just realized it's sort of a clunky way of showing it. But this is how you can look and know that you got them all exhaustively. And the key is just sort of looking at your set and just dropping pieces out. What's the greatest odd factor? So neither of the 2's can be in an odd factor at all, right? Because they're going to force it to be even, right? So it has to be 3, 3, 5, which is 45, right? And then this here would be 60. There may be easier ways. You could probably sort of think your way through this one without doing such an in-depth analysis. In fact, right off the bat, I'd probably just go with 60 and 45. But just if you're sort of worried about it or you want to make sure you know, this technique will always work to make sure you know you got all the factors. Okay, certain integer n is a multiple of both 5 and 9. Which of the following must be true? N is an odd integer. Does that have to be true? Why not?
Because if it's a multiple of 5, it can have a 0, or it's a number, or like there can be 30 or something. But
Well, 90.
well, I mean, it has a 0 at the end. So.
Right, 90 would be a great example. I would just try and think of one just to double check that. But yeah, absolutely. N is equal to 45.
Yeah.
Yeah.
That has to be true?
No.
No.
Has to be.
Yep. And notice it says which of the following must be true. And they'll do stuff like that all the time to trick you. They'll say like, oh, it's going to be 45, because that's when you're like, oh, it's obviously 45 is a factor. But that's not going to be the case. N is a multiple of 15. So obviously, since we didn't get either of the first 2, this one would have to be the answer. But just to show you how you can also prove that, you can do this prime factorization. So again, you can tell just from the structure of the question, I wouldn't actually do this because you'd be like, oh, 3 has to be true, and it seems right. But if you take 5 and then you take, again, the prime factors of 9, right? Anything that is a multiple of both of these will contain all of those. It can contain a lot of other things, but it will contain those. So, like I could put, more and more 5s here, but it's going to contain these, right? Well, you'll notice that that would be 15 right there. Does that make sense? Yeah.
Yep.
Okay. So again, you don't necessarily need to do this all the time, but I'm just sort of trying to drill in the idea of these prime factorizations give you these sort of fundamental pieces of numbers, and then you can recombine them in different ways, and you can look at all the different combinations, and you can actually get a lot of information out of it.